Hi everyone. My name is Siddharth. I'm going to now get to the slides for the short story paper assignment. Okay. So, um, this is what we're going to talk about. This is my presentation for Compy 255 data mining short story assignment. My topic is, can AI keep online gaming civil? A direct look into how machine learning and large language models can detect toxic messages in real-time gaming chats. This work is based off on a 2025 study by Yehor Tereshnenko and Mika titled A Comparative Study on Toxicity Detection in Gaming Chats Using Machine Learning and Large Language Models. So, online games today are more than entertainment. They are social spaces where millions of players interact every second. That constant communication brings energy and teamwork, but it also opens the door to toxic behavior, harassment, hate speech, and verbal abuse. Now, imagine trying to moderate millions of chat messages every minute. It's nearly impossible for humans alone. That's why researchers are looking to artificial intelligence to see if machines can step in, read the tone of a conversation, and recognize when something crosses the line. However, now the question is, can AI actually tell the difference between a friendly banter and real abuse? This paper compares three families of AI models for this task. The first is the traditional machine learning, things like logistic regression or support vector machines trained on word frequencies and embeddings. They are lightweight and fast but can't always understand context or sarcasm. The second approach is fine-tuned transformer models such as distilled BERT. These are smaller versions of BERT that can be retrained specifically on gaming chat data. Finally, the authors tested large language models or LLMs using zero shot or few shot prompting. In other words, asking models like GPT to classify messages without heavy retraining. The goal was to find which system gives the best balance between accuracy, speed, and cost. Now, the results showed a clear winner. Distilbert achieved the best trade-off between accuracy and efficiency. It understood slang nuance for better than traditional models, yet it was fast enough for real-time moderation. On the other hand, large language models perform very well in understanding context. They could catch new or subtle insults, but they were simply too expensive and too slow to run continuously at scale. So the paper concludes that a hybrid system works best. AI handles most of the filtering, while humans review ambiguous or high risk cases. This project connects directly to several data mining concepts from our course. Toxicity detection is essentially a text classification problem where messages are labeled as toxic or non toxic. It uses pattern mining to uncover recurring abusive phrases and clustering to group similar behaviors among users. To process text, it relies on dimensionality reduction, turning thousands of word features into compact embeddings. Finally, the study evaluates models using metrics we have learned: precision, recall, F1 score, balancing correctness with coverage. But accuracy isn't everything. Moderation is about people, about fairness and empathy. If the model mislabels a harmless joke as toxic, players feel censored or misunderstood. If it misses genuine harassment, the community suffers. The authors emphasize that no AI system should operate alone. Instead, we should combine automated screening with human review, ensuring context is never lost. So, what do we learn from all of this? AI is not a silver bullet, but it's an incredible assistant. By fine tuning lightweight transformers and combining them with human oversight, we can make gaming spaces safer without killing the spirit. It's a powerful example of how data mining and NLP can transform chaotic, unstructured text into actionable insight. In this case, identifying toxicity before it spreads. As future engineers and data scientists, it's our job to design systems that are not just smart, but responsible. Thank you for watching my presentation. Once again, I'm Siddharth, and this was my Compy 255 short story project on toxicity detection in gaming chats using machine learning and large language models. And special thanks to the authors for their excellent research published on ARXIV in 2025. Thank you.